Hi students, we're going to be looking at some horizontal transformations of graphs of sine and cosine. We're going to ignore the vertical stuff today, so we're not talking about amplitude or midline. We are going to be talking about the other two things, which are phase shift and period. Okay, so we're going to graph these things in a little bit of a different way than we looked at before. And for that, I'm going to think about my beginning and end point for my graph. So my beginning point is going to be at x equals 0. My end point is going to be at x equals 2 pi. This is going to be true for any trig graph that we look at for sine and cosine. Tangent is a slightly different thing, but we're not going to worry about that yet. What I'm going to do is take the stuff on the inside and set that equal, and they use theta, I used x, that both mean the same thing, it's okay for these graphs. I'm going to set that equal to the beginning and the end point. So I'm going to call this the start, and I'm going to say x is equal to, and I like that I screwed that up immediately, that 0 is equal to 2 theta or 2x. To get theta by itself, we're going to divide by 2, and we get 0 is equal to theta. That means that my first point is going to be at x equals 0. Okay. My ending point, I'm going to do the same thing, but set it equal to 2 pi instead of 0. So 2 pi is equal to 2 theta. Divide both sides by 2, and I get theta is equal to pi. That's my ending point for my cycle. So instead of being at 2 pi, my new graph is going to be at pi instead. And here again is the nice thing about trig. Because it is periodic and symmetric, we can do some really cool things. Exactly between these 2 points, just like exactly between the 2 points we see here, is going to be the bottom of my graph. And exactly between the x values for each of those are going to be the points that fall on the midline for cosine. So my graph is going to look like this, where I go down to the bottom, back to the midline, then back to the top. What I'd like for you to notice is that this graph has been squished by a factor of 2, so it's half as wide as it once was. We talked about this with transformations as well, but it was a little bit difficult to see with non-trig graphs. Looking at our second one, we're going to do the same exact thing. We're going to start with 0 is equal to 3 theta. That's my starting value, and that tells me that theta equals 0 is going to be my starting value here. All right, let's do that for our end point. So we've got 2 pi is equal to 3 theta. And solving that, we get 2 pi over 3. Okay, this is pi, so we're dividing this into 3 pieces. This would be 1 pi over 3. This would be 2 pi over 3. That's going to be my end point here. Because we're doing a sine-shaped graph, exactly in the middle of these 2 endpoints, I have the point that was also on the midline. That's going to be here. And then exactly between each of these points, we're going to be at the top. And then between the middle and end, we're going to be at the bottom. So we get the same sine-shaped graph, but this is squished by a factor of 3. It's 3 times narrower than it was before. All right, so now we've got to write a cosine function. And to do this, we're going to make use of a couple different things. The first thing we got to do is to figure out what the heck one full cycle of this is going to be. And for that, I'm looking at, okay, we're going from here to here. So I'm going to look at my scale. Here's 0, here's pi. We've got 1, 2, 3, 4 steps to get to pi. So these are fourths, because that's 0 to 1. If we cut that into 4, that's fourths. So that'd be pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. To get this number, we're going to work a little bit backwards. And to do that, we're going to use a really useful relationship, which is that 2 pi is always going to equal our period times the b value in our equation. So I'm talking about this. So cosine of b times x. That's going to be true any way we look at this. And anytime that we have one of these, we can always figure this out by going backwards. So here we've got 2 pi is equal to, and we said the period is pi over 4, multiplied by that b value. To get b by itself, I'm going to multiply by 4 and divide by pi. Dividing by pi is going to make those pi's go away. And multiplying by 4 is going to give us 8 is equal to b. I like how I wrote pi instead of b there. So what we're looking at is an equation cosine of 8x as our function. And if we think about this, so the function was an original period of 2 pi because it's cosine. And suddenly we have 1, 2, 3, 4, 5, 6, 7, 8. 8 of them now fit where one of them used to. That's another way to do this, but we can't always get that information from our picture, so it's helpful to have an equation that looks like this. All right, so what we're going to look at here is what happens if we do a horizontal shift. And I'm going to ignore that amplitude out front just to keep that separate for a little bit. So we're just going to cross that part out. And I'm going to do the same thing. So we know that a sine function starts at 0 and goes to 2 pi. So I'm going to start, and I'm going to put that whole inside equal to 0. So theta plus 2 pi over 3 is equal to 0. That gives me theta is equal to negative 2 pi over 3 when I get that by itself. And that's going to be my starting point here. I'm going to color code these. Let's do an ending point. Same thing. Theta is equal to 2 pi over 3. Sorry, I just put an equals instead of a plus. And that's going to be equals 2 pi. To get that by itself, I'm going to minus 2 pi over 3 to both sides. And I know that everybody's favorite things are fractions, so I'm going to talk about that as part of this as well. To combine fractions, we need common denominators. And if I want something over 3, it's got to be with times 3 over 3. So this is really 6 pi over 3 minus 2 pi over 3, which is 4 pi over 3. So what's 1, 2, 3, 4 pi over 3. And the same thing, I'm going to go exactly in the middle. So that's 1, 2, 3, 4, 5, 6. In the middle is going to be my third point on that midline. Sine goes up first. Exactly between those two is my peak, and exactly between the other ones is my trough. And I went way too far down for that. Come on, eraser, you can do it. There we go. So my graph would look like this. Okay, so what happens if we have both of these at the same time? Using this method of graphing, the nice thing is we don't have to worry about any weird things happening. We can use that same method. So 2 theta, I'm going to call this the start, plus pi is equal to 0. That's always the starting point. Minus pi to the other side to get 2 theta is negative pi. Divide by 2, we get theta is negative pi over 2. All right, we're going up by pi's over 2, so there's my positive pi over 2. Negative pi over 2 is listed there. Here is my starting point. Switching colors. For the end point, same thing. 2 theta plus pi, and again, if you prefer, you can certainly use x there, is equal to 2 pi. End is always equal to 2 pi every single time. Minus pi, we end up with 2 theta is equal to pi, divide by 2, and theta is equal to pi over 2. Here's my pi over 2 point. This is sine. I'm going to go exactly in between those two, And my point on the midline is going to be right at 0. Then I'm going to go exactly between those again on both sides. Positive sign goes up first and then down. And here is our function. Let's do one more of these. Again, same thing. I'm going to start with the inside, so 1/2. And again, if you prefer to use x, totally fine. And that's going to be equal to 0. I'm going to minus pi to the other side. We get 1/2 x is equal to negative pi. Multiply by 2 to get rid of the 1/2. And I got x is equal to negative 2 pi. All right, cosine, so cosine starts at the top. That's going to be down here. Let's go with an ending point. 1/2 x plus pi is equal to 2 pi. When I minus pi to both sides, we got 1/2 x is equal to pi. I'm going to multiply both sides by 2 to get x is equal to 2 pi. Okay, there's my ending point. Cosine ends at the top, so there's my end. All right, the middle point, I'm going to go exactly between those two, and that's going to be at 0. Middle point of cosine is going to be at the bottom. And then I'm going to cut those in half again. So we're looking at between 0 and negative 2 pi is going to be just in between there. And then we're doing the same thing on the other side, so that my graph looks like this.